Window Selection Guide Part 3. Basic Performance Requirements. Once the preferred operator type is selected for the application, a window, door, or skylight must be designed to withstand the conditions of the specific climatic location and type of building in which it will be installed. In this course, we will introduce the basic performance requirements related to selecting fenestration products. Specifically, we will cover air, water, and structural performance in more detail, as well as some important safety considerations. It is also critical that the product is properly installed if its design benefits are to be realized. Remember that maximum performance is based on the installer's knowledge of proper procedures. It is important to follow the installation procedures completely, and if the installer has concerns, the responsible parties on the project should be consulted. The conditions under which the installed unit must serve may be determined in a variety of ways, and these must be matched up with the performance requirements defined by published window and door industry standards and applicable local code requirements. For windows and doors, these requirements are detailed in the most current version of AMA WDMA CSA 101 IS2 A440, also known as the North American Fenestration Standard, or NAFS. The basic performance requirements include air filtration resistance, water penetration resistance, uniform structural loading, forced entry resistance. The ability of windows to meet these primary performance requirements is determined by laboratory tests following methods described with the AMA standards and ASTM test methods. In addition, there are a number of other requirements which are operator and material dependent. The tests for air infiltration, water penetration, and uniform loading are all conducted in the same type of test chamber, essentially a sealed box with one open side in which the test window is installed and sealed. The box is equipped with a controllable blower, which is designed to provide the specified test air pressure difference across the test window. Measuring devices record the test pressure and airflow. Air leakage describes air flowing through and around the sash and frame. Air leakage is divided into air infiltration, air moving from the exterior to the interior of a building, and air exfiltration, movement of air from the interior to the exterior. Excessive air leakage can cause heat loss in winter, heat gain in summer, occasional increase in indoor humidity in summer, drafts and discomfort, and higher utility bills. Air leakage is driven by pressure differences between the indoor and outdoor areas at the window. The greater this difference in pressure, the higher the potential for air leakage. Pressure differences can be heightened and air leakage worsened by the stack effect, which pushes air up and out of cracks at the top of the building. HVAC duct systems and ventilation fans also create pressure differences by pulling air from one part of the building and, in some cases, supplying it to another part. New windows and doors are rated for air infiltration. Tests are conducted by establishing a pressure difference across the window that simulates the impact of winds at various velocities. The ratings are based on cubic feet per minute, or CFM, of air that flows through the product in relation to its area. Air leakage can be decreased by controlling pressures in the building, installing airtight products, typically those with a rating at or below 0.30 cubic feet per minute, fully sealing products to the building air or vapor barrier, and ensuring that the installer follows the manufacturer's instructions and industry guidelines. The combination of wind pressure and driving rain can force water around the seals, between the operable sash and frames, and through sealant joints and small pinholes in the surrounding building materials. Because water is typically forced from higher pressure areas into areas with lower pressure, water resistance test pressures must take into account the wind load design pressure that a product must withstand in order to meet a specific performance level. Accordingly, the test to measure a window's resistance to water penetration consists of spraying water uniformly against the exterior surface while applying a specified static test pressure, which simulates the actual wind. Water is applied at a minimum rate of 5 gallons per hour per square foot of window area. This is the approximate minimum rate required to develop a uniform film on fenestration products. Satisfactory performance means that there can be no penetration of water into the plane of the innermost face of the test window or through the window frame during the specified test period. To help control water penetration, windows and doors are designed with either compression seals or sliding seals, commonly called weather seals. Compression sealed products are designed to be airtight on the inside and to incorporate pressure equalized drainage cavities. Sliding seal products are designed to seal between the sash and frame while allowing for the sash's sliding motion. Additional features such as weep holes in the sill and special installation accessories allow for the collection and drainage of water to the outside. We will cover some of the accessories later, but it is important to understand that proper installation is as important to controlling water penetration as the design of the window itself. Another factor used in determining the correct grade window or door is the product's ability to withstand wind loads. When establishing performance expectations, consider geographical location, terrain, height, and local wind speed. The performance grade defines the minimum uniform design pressure due to wind and the associated performance requirements in accordance with NAFs that a product must withstand in order to qualify for the conditions at a specific building site. As its name implies, the purpose of the structural test is to determine the structural adequacy of the window when exposed to maximum expected wind pressure, which is known as a design pressure. To conduct the test, the window is exposed to an air pressure equal to 1.5 times the design pressure. The window is tested with the load applied to the exterior side and then the interior side, or vice versa. A window passes the test if there is no glass breakage or permanent damage to fasteners, hardware parts, support arms, or actuating mechanisms. There is no other damage which would cause the window to be inoperable, and there is no permanent deformation of any mainframe, sash, leaf, or threshold, or sill beyond the limits identified in NAFs. NAFs establishes a minimum or gateway test size for each performance class in which the various performance requirements of all windows are to be measured. A window manufacturer may test a larger size, such as the largest size available in a given product line of the same design, and thereby qualify all smaller sizes within that product line. Product certification labels validate that a window or door has been tested and authorized to be certified for compliance with the requirements of the NAFs standard. AMA's certification program, which originated in 1962, is an objective and independently validated third-party program accredited by ANSI, the American National Standards Institute. Labeled products are tested at an AMA-accredited lab, tested to all requirements of the NAFs specification, produced by AMA-licensed manufacturers, manufactured in plants subject to 2 unannounced annual compliance inspections, assembled with verified components and certified profiles, and listed in the online AMA Certified Products Directory, CPD. Critical safety issues also impact the design and function of various fenestration products. These are fire and emergency egress, safety glass, insect screen safety. An egress window must be operable from the inside without the use of tools or special knowledge. Typical egress window dimensions must meet a minimum of 5.7 square feet clear opening, with minimum opening dimensions width of 20 inches and height of 24 inches. Safety glass is typically tempered glass and is often required within 18 inches of a door or entrance. Most codes require safety glass where a window or glazed door may be subject to human impact. In terms of screen safety, interest in this topic has increased due to incidents of child falls from windows. It should be emphasized that screens are designed and intended for preventing the entry of insects. The latches that keep the screens in place allow for easy removal for cleaning and storage. These latches will not hold up under the weight of even a small child. Most new window screens carry a permanent child safety label as shown here. AMA co-published a brochure that presents child fall prevention guidance including screen safety tips. If a homeowner asks about fall prevention or screen safety, recommend the following. Whenever possible, open the windows from the top. If you open the windows from the bottom, open 4 inches or less. Do not place furniture that a child could climb on in front of an unguarded window. Consider using properly installed window guards that are compliant with building and fire codes, and plant shrubs or grass under windows to cushion potential falls. Congratulations! You have now learned the primary window and door performance criteria, as well as some important safety considerations.